Today we are going to present a system for recognizing English fonts of degraded character images using normalized central moments feature with support vector machine SVM as a classifier. This is the structure of the presentation. First, a system design will be shown and illustrated. Next, the steps that has been used in the pre-processing will be presented. Then we are going to talk about feature extraction algorithms and classification. After that, the results that we got will be discussed and presented. Finally, the conclusion that we got will be shown. As any recognition system, there is three main steps: pre-processing, feature extraction, and classification. Here in the right side is the diagram of our system. Here a character image will be entered to the system. It will go through pre-processing. Next, its feature will be extracted, then normalized. To know the font class of a character image, the system first must be trained and the model of an SVM be created. After creating a model, now we will be able to know the class of the font of character images. For the recognition, we will go through this site and test the character image to recognize its font. All the samples that has been used in this paper was obtained from Al-Khaffaf's work in 2012. All the character images are PNG file format of size 102 by 102 pixel with 8-bit per pixel. To reduce the processing time, we decided to shrink the image 51 by 51 pixels. Next, the image has been converted into a binary 0 or 1. Then noise has been removed by the median filter of size 5 by 5. After that, two kinds of feature extraction algorithm has been applied: distance profile feature and normalized central moment separately. Each kind of feature has been saved in a comma-separable file, CSV file. Distance profile feature DP is a histogram feature that calculates background pixel of a character image. Because the image is of size 51 by 51 pixel, it calculates 51 left distance profile and 51 right distance profile features. And for the two diagonals, main diagonal and secondary diagonal, it calculates 4 features. For the main diagonal, top left corner and bottom right corner are calculated. And for the secondary diagonal, top right corner with bottom left corner are calculated. In total, we have 106 features. To obtain normalized central moment features, first we have to find out the moments by the following equation: M sub P and Q equal summation of x, summation of y, x to power p, y to power q, f of x, y. Summation of p and q is the order of the moment. X is the value of the row and y is the value of the column, while f of x, y is the pixel intensity. Then we will calculate central moments by the following equation. Here x bar and y bar are the center of gravity. After that, normalized central moments feature are calculated by the following equation, where gamma is equal to p plus q divided by 2 all plus 1, and the output will be 10 features. Experimental steps. As mentioned before, a dataset was obtained from Al-Khafaf's work in 2012 of size 27,620 degraded character images of three fonts: Comic, Deja Vu, and Times. Here in the right are the samples of the dataset, where top characters are Comic font, and the middle one are the Deja Vu font, and in the bottom are the Times font. Because the system has three stages: training, validation, and testing, we divide our sample according to the three stages to three sets. 64% of the data set has been used in the training, while 16% is used for the validation and the remaining 20% is used for the testing. The samples that has been used in the training are not used in the validation and testing, and the same thing is for validation and testing, where each sample is used only once. As mentioned before, we use support vector machine SVM as a classifier, which is supervised learning algorithm. Our data are non-linearly separable. That's why we use the RBF kernel to train the model and identify the font class. In the validation, 75 experiments for various trials has been done depending on the value of C and gamma parameter of SVM with RBF kernel. We arbitrarily choose three gamma values: 1 over 10, 1 over 26, and 1 over 106, where 1 over 10 denoted by G10, and the same thing for the others. For normalized central moment features, here the light green dot when C is 35 and G gamma is 26, 1 over 26 as base recognition rate. The same process has been done for the distance profile features. In the testing, the selected pair of gamma and C has been used. For the distance profile, best pair was when gamma is 1 over 10 and C equals 7. The recognition rate was 94.82%. While for the normalized central moment, the best pair was gamma 1 over 26 and C is 35, with recognition rate 94.9%. To compare our work with other works like Bharat's work in 2017, where he used a distance profile feature with a support vector machine as a classifier. He used 74 distance profile features of clean images, and he obtained 80% recognition accuracy. Another comparison has been done depending on the dataset, which is Khafaf's work in 2018. They had higher recognition accuracy of 97% compared to our result. They used smaller dataset of 6,144 samples only, which is 4 times smaller than our dataset. While in our system we used 27,620 samples in the training, validation, and testing. The recognition rate of our system is about less than 3% smaller than Al-Khafaf's work. Al-Khafaf's work also used a principal component analysis (PCA) to reduce the number of features. In conclusion, our system has two advantages. First, we used a large data set compared to previous studies. That helps getting better cognition accuracy. The second advantages is that we use the validation stage for deciding the SVM parameters. That helps us reducing amount of processing time for obtaining best recognition accuracy. In the future, we intend to use principal component analysis PCA to reduce amount of features to get better recognition accuracy. And we will try other types of feature extraction algorithms to enhance the accuracy of our system. Thank you.